we will be talking about this concept of the modern data analytics stack. We'll just give a quick overview of what that is. We'll talk about how Tellius fits into this stack and really talk about the 3, or rather 4 must-haves for modern analytics. I know we promoted this as 3. I really couldn't get out of the 4th one, so you guys get a bonus must-have that we get to talk about here today. Socket will give a live demonstration so you can see Tellius in action, and then after that we'll take your questions. So actually feel free to enter in questions into the Q&A window as they come to you, and we will address those at the end. Now, before we jump into Modern Data Analytics Stack, I just wanted to offer just a slightly different perspective on how I think about the modern data stack, right? So today we live in the age of the internet and the cloud, right? Every device is connected to infinite data storage, infinite processing power, and all of this is available in your fingertips, on your phone, on any device that's, and it's readily available to you, and it's all available on demand. Now, imagine a scenario where phones and computers didn't exist, right? And I said to you, well, the only way you can, and I said to you, look, packets can still be delivered, across the world in 7 milliseconds, but the only way you could actually access the internet was by using an old rotary phone. And by the way, if you were to make a phone call, you'd actually have to talk to someone on the switchboard and get connected manually, and and you would have to talk to them, and you'd have to talk to another switchboard operator on the other side. And you think to yourself, well, this is crazy. This really can't be the way modern technology works. We have all this great plumbing at work for me, and yet I have this really poor experience upfront to access those technologies. And believe it or not, this is an analogy. This is how I think about modern analytics today on top of the modern data analytics stack. So let's jump into this modern data analytics stack. Now, if you're like me, you might have read a lot of different articles out there on the internet about the modern data analytics stack. And so what I'm showing you here right now is really a combination of different things that I've seen in the research and how many people think about the different layers in this stack. So in this stack, right at the bottom, there's your data sources, whether they are applications or databases or files that you're looking to centralize and bring data together into a centralized place. Then you have an ingestion layer where you're choosing one or perhaps multiple tools to connect to your data sources, go through an ELT process to actually extract that data from those source systems into your storage layer. And in your storage layer, you have very popular, what's become very popular in recent years are cloud data warehouses, or perhaps one or more cloud data lakes or lake houses there in the storage layer, right? And so Snowflake, Redshift, BigQuery, these are examples of data warehouses. And then you see Databricks, S3, and Azure Data Lake also on the data lake side of things. And if you read different influencers and you talk to different vendors, there's this fight between the data warehouses and data lakes, and they're kind of colliding, taking different approaches, taking different points of view, and really kind of combining into perhaps one data lake warehouse vision in the future. So that's what's happening on the storage side. You also have data transformation tools such as dbt as well, sitting alongside these data stores, so that you're actually doing the transformation at the storage layer, which is unlike what has happened in the past. And then there's also operational applications as well to help you with the governance, with data observability, all these different processes that you have in place. And what's great about the modern data stack here is that this stack can be stood up in the cloud in minutes. You can pay as you go. It's very easy for someone to just get this up and running, and all the pieces are just very plug and play. So if you decide to change out vendors, you can just plop another service provider into your stack very easily. Okay, and so with this vision, I think from the standpoint of data, this vision, and when you talk to people that have implemented a modern data stack, it's quite grandiose, right? So the idea is that now all your data from your multiple sources, it's all centralized. You've got your metrics fully defined, access is governed, and you have this, headed towards this data nirvana, if you will. And then what's interesting is after you've got that, then you think, okay, well, let's look at the analytics layer on top of it, right? So analytics, from an analytics point of view, many people think about dashboards. So now you can, monitor your standard metrics in a dashboard. You can do things like query, right? When you're using SQL or Python, you can query your data stores, or you're using data science, right? So now that you've got the data, you can extract it, you can build some data science models, do some predictive models. But I think this is where the point that I always think is interesting, which is, well, I often ask myself, well, how modern is the analytics layer, in fact, that most people have a vision for, right? And I would argue that the current state is really not that modern. When you look at dashboards, right? Dashboards and the concept of executive dashboards, this was invented in the 70s, right? SQL as a query language was also invented in the 70s. And by the way, statistical software was also invented in the 70s as well. Now, it took a different format, had a different name, but for a lot of business data analysis, it still relies on linear regression, which, for some old timers, right, statisticians and folks in the data science field, they're like, okay, well, this is rather old hat. Now, that's not to say that these pieces are not essential. In fact, no, absolutely the opposite. These are very core pieces to many analytics programs out there. And in fact, I myself, if I might add, was also born in the 70s. So I think that, my perspective is also that, hey, these are great essential pieces that you need to have. But I would argue, isn't really that new or modern, right? And at times it can actually not leverage the other pieces of your modern data stack in order for you to extract insights in the most efficient way. So therein lies then the question of, okay, well, what are the things that are needed to bring analytics into the more modern age? And number one would be automated generation of insights. Okay, now it's a bit of a mouthful, but at the end of the day, this is about how to automate the data analysis process to get insights a lot faster, a lot easier to those who need it, right? So we live in a world today where you have so much data that's stored in the cloud, right? And it's really too much, right? And we're talking about data that is not only wide, data sets that are wide, data sets that are deep in volume, the complexity of the data inside of it, and you think about the different relationships that you have between tables, between bringing together data silos, right, and how those are interconnected. There's so many more different patterns and relationships that exist that you couldn't possibly, analyze the data manually to find, right, or to see, or even, quite frankly, query by code, right? Because if you're writing a SQL statement, you're already kind of know exactly what you're going after, and oftentimes you're just seeing, a small slice or one small sliver of that data that you're going for. Okay, and so what the automation allows you to do then is to analyze all the possible combinations of data that you have. So instead of coming up with a hypothesis, right, and then testing each one of those hypotheses individually, why not utilize the compute power that you have available to you to actually look across all of your data to find and discover the insights that you need at a really granular level. And what's great about this is that you now come out of a place where you only find the things you're looking for. You come out of a place where there may be confirmation bias, and you go towards a place where you're able to discover what the unknown unknowns are, things you would not have thought of, relationships you would not have thought of, right? Outliers you would not have otherwise seen now become more visible to you. And on top of that, the automation would then also allow you to get more proactive insights where they will learn from your interest, understand what data is important to you, what metrics are important to you, what insights are important to you, and then allow for those insights to be automatically fed to you over time instead of having you to bring up a dashboard and look for certain things that you're used to looking for. Now, another way that I'll put it is, at the end of the day, traditional analysis is not scalable. So here's just a really quick example. So if you think about it, just a data set with just 20 variables, and really there are more than 6,000 different chart combinations that you'd have to create or analyze, even if you're just analyzing 4 variables at a time. Okay, so think about that for a second, right? It's literally impossible to even come up with so many SQL queries. Never mind bring up a visualization where you need to spot, different trends and outliers, right? And again, the idea here is that what's available in your data is not just broad swaths of analysis, right? It's about really granular types of insights that allow you to understand and take specific actions that you want to take. Okay. And what this also opens up is that you'll not only understand the what is happening in your business, but also much more easily understand the why, okay? By being able to get deeper insights much faster and with a single click of analysis, you would then have a much greater variety and availability of insights for you to understand key drivers of your business, right? Like what are those top 3 to 5 different factors that are most importantly driving those metrics. You can understand trends and understand why was performance this week greater or better or perhaps the same as last week, right? And really delve into what's happening in your data. You can do cohort analysis, so you can actually compare, let's say performance across regions, across salespeople, right? Across marketing campaigns, much more easily instead of diving into the data and manually figuring out what the differences are, right? Segments, anomalies, there's so many more different types of analysis that would be accessible to you. So that's number 1, automated generation of insights. Number 2, to make analytics more modern would be natural language, right? And so the idea is that with automation, you're making your existing analysts, your data experts that much more powerful. With natural language, you're making data more accessible, perhaps, for humans, right? I dare say, I don't want to say for the less technical people or non-technical people, but just more accessible to everyone who wants to understand data without requiring them to know SQL, to understand code, even come up with keywords, or even understand syntax for that matter, okay? This would allow many more people to be able to ask questions in natural language and also have some capability of being forgiving of mistakes, right? So you think about for perhaps Siri, right? Or that type of capability for your data. With natural language, it would also help really anyone interpret insights as well, right? So if you think about the current state of just simply data visualization, someone actually has to look at a chart and understand, hey, what am I seeing here, right? What are the differences that I need to spot when I'm looking at a visualization? But that can be further supplemented through auto-generated narratives and stories about these insights and about this data that would then make it much more clear what the important findings are in your insights. And with natural language, the current state of natural language today would also be able to adapt to business-specific vocabularies and words that are specific to your business, so you can further, just seamlessly dive into the data, or even have multilingual capabilities to make it more accessible, to a wider audience. And with natural language, it can work hand in hand with the automation as well. So you think about this modern analytics experience, right? It might actually start by someone asking a basic question, in this case about, let's say, drug prescriptions in the Northeast and why did they drop, right? So instead of you manually slicing and dicing across every section of the data, the system will scan through the data to automatically identify those key contributors of change so you can understand a deeper of what's changed. And then from there, you can look across all the different measures that's correlated to performance to understand just why these changes have occurred. And then as a last step, you can also learn how to improve the situation by examining the different segments of customers or transactions tied to the business outcomes you're targeting. And in this example, even have your sales and marketing team focus in on those areas. So it's about having a more guided process to get you through the journey from data to actions. So that's 2 for natural language. Now, number 3 would be machine learning for non-data scientists. Now, again, right, so machine learning has been certainly the purview of expert data scientists, even PhDs for a very long time. But here the goal would be to empower a new generation of analysts armed with data science. So you're making it much more accessible, allowing them to create predictive models or clustering or regression or different types of models via some point and click capabilities and automated machine learning. Now, the important part of this is to couple that with visualization to enhance the explainability and also the transparency of these models as well. So they not only they can understand it, but they can also help other people understand what those findings are from machine learning. And a core piece of the AutoML would be the automated feature engineering underneath of this. So remember, even data scientists will complain that, in fact, data prep is really the hard work when it comes to performing data science. It's not so much the modeling part, but as much as you can automate the feature engineering to simplify that data preparation would certainly go a long way to making the data science more accessible. So when we revisit now what the modern analytics would look like inside of the modern data stack, we see that the key is really this thinking of not just having BI and AI data science be separate things, but looking at how they can be merged together to empower a new set of capabilities to bring organizations forward and deepen their understanding of data. So on top of what I had before for dashboards, for query and expert data science would be natural language search. So again, someone can ask questions in natural language, AI guided insights, so to automate the analysis process, and then something called citizen data science, again, making data science much more accessible to a wider audience. So that covers the first 3 things. So now you might add, well, what's the 4th thing? So the 4th thing is that you have to understand that analytics sits on top of the other pieces of the data stack. So the 4th thing is to efficiently leverage the in-data warehouse or the in-data lake compute power of the underlying storage layer, right? So the idea is that you have this great set of technologies underneath you. You want to optimize performance of the resources and the infrastructure you have, but the analytics part needs to be flexible enough at the analytics data interaction point to be able to leverage the underlying technologies. And at Tellius here, we actually support 3 different modes of processing, right? So on the left side here, you see what you might commonly see from some BI tools is that we'll automatically generate SQL. So if you want to push down queries into your SQL stores, that's certainly possible to basically push down the compute onto that layer and then have the response retrieved, for us to then present to users. We can also auto-generate ML jobs as well. So we can actually push and generate and leverage ML processing at the data lake level, okay, off of our system and utilize your existing resources for ML jobs. And then the 3rd mode of processing is that, sure, there may be cases, in spite of you leveraging the modern data stack, where data does need to be ingested into our system. And that's perfectly fine by us because we do have what we call a dual analytics engine that handles both very fast BI query and also very fast AI ML processing as well that's leveraging Spark in our system. So for those cases where you're using, we need to connect to other data sources that may not be going through your data warehouse, or you're doing some prototyping, we can definitely support those types of use cases as well.